We're going to start off by going over side, side, side triangle congruence. Probably one of the most obvious, yet most complex forms of triangle congruence. What it's saying is, you notice you have a triangle and you have three side lengths, 5, 6, and 7, my triangle ABC. What it's saying is there is no other possible triangle that you can make with the side lengths of 5, 6, and 7. No matter what you do, even if it's rotated, that triangle is going to have the exact same angle measures, the exact same perimeter, the exact same area. It's also saying, if you notice you have three side lengths of one triangle congruent to three side lengths of another triangle, then those corresponding angles are going to be congruent. So what do I mean by corresponding angles? Because we're used to that with lines and transversals. It's the angles that are on the same side of each group of lines and the same side of the transversal. So corresponding means the exact same thing here. It's going to be the angles in the same position. So here, if I'm looking at angle A, it's between the side length of 6 and 7. So on the green triangle, the angle between 6 and 7 is angle E. So those would be considered corresponding angles. To write that down, we'd say angle A is congruent to angle E. We could work with another angle too. If we were wanting to focus on angle B, it's between the side length of 5 and 7. So the corresponding angle would also have to be between the side length of 5 and 7, so that's angle F. So we could say angle B is congruent to angle F. That means if angle B was 50 degrees, we automatically know that angle F is going to be 50 degrees. And last but not least, we know that angle C has to be congruent to the other angle that's between the 5 and the 6, so angle D. Another thing I might ask you to do is I might ask you to find a triangle congruence statement. That means if I would say triangle A, B, C is congruent to, and now you need to match everything up. A is congruent to angle E. So I'd start, my first letter was A here, so my first letter has to be E here. I said my second letter is B. B is congruent to F. That's an F. And then my third letter is C. C is congruent to D. So we're saying triangle ABC is congruent to triangle EFD. We could switch the orders around. Like, let's say I wanted to write triangle BCA is congruent to another triangle. Well, B is my first letter. We know that B is congruent to F, so F is going to be my first letter. C is my second letter, so C is congruent to D, so D will be my second letter. And A is my last letter. Well, A is congruent to E, so E is going to be my last letter, if I could write it. So that means triangle BCA is congruent to triangle FDE. So triangle congruence, if you look at it, like this example right here, they're not just rotating the triangle. Sometimes they're reflecting and sometimes they're rotating. But if I have three side lengths of one triangle equal to three side lengths of another triangle, that means that the triangles are congruent. So that means the angle between 7 and 15, angle S, is going to be the same measure as the angle between 7 and 15. So we put a little curve on it. That means the angle between 7 and 9, I'm going to put two curves because it's the second angle I'm talking about, is going to be congruent to the angle between 7 and 9. the angle between 9 and 15, this is my third angle, I'm going to put 3 marks on it, is going to be congruent between the angle of 9 and 15. So I could say some quick things about this. I could say angle S is congruent to angle U, really quick because of the fact that they both have one little curve on it. I could say side SR is congruent to side UV. Now this is really important. SR is congruent to UV. I can't say it's congruent to VU. I have to make sure that still I'm working with the angle with one curve on it is the first letter. The angle with 3 curves is the second letter. So we're not going to flip the order around anymore. We're going to be very specific. And that makes sense because SR is 15 and UV is 15. Okay. I could say side QR is congruent to side TV because Q has 2 marks, T has 2 marks, R has 3 marks, V has 3 marks. I could say triangle RSQ is congruent to triangle, and now I need to look at the markings. R has 3 marks, so the other angle with 3 marks is V. S has 1 mark, so the other angle that has 1 mark is U. And Q has 2 marks, so the other angle that has 2 marks is T. It's pretty obvious to tell that these triangles are not congruent based on their side lengths, because one is 777, one is 666. So I don't want y'all to think that side, side, side stands for 3 side lengths being the same length. So what it is it's saying that, like, the first side, let's just mix up that one of the sides is the first side of one triangle, would have to be congruent to another side on the other triangle. And then let's pick up a second side of one triangle has to be congruent to a second side on another triangle. And then a third side of one triangle has to be congruent to the third side of the other triangle. So I think we can agree on this next example that the pictures are not drawn to scale, but I know that the triangles are going to be congruent because they both have a side length of 11, they both have a side length of 12.5, and they both have a side length of 13. So the type of question that it may ask is, if angle A is, I don't know, I'm just making something up, 40 degrees, 40, not 46, okay, 40 degrees, what other angle do I automatically know? This is when you have to understand what is the same angle, what is the corresponding angle of angle A in the other triangle. So angle A is between the 12.5 and the 13. Between the 12.5 and the 13 is angle D. So that means automatically we know that angle D is 40 degrees. Likewise, I could say angle C is 50 degrees. It doesn't quite make sense. Okay, so angle D is 50 degrees. And then you know that the side between the 11 and the 13 would also have to be 50 degrees. But, you know, we're going to make it a little mathy. So what if I said it was 2x plus 5 degrees? Again, we know that angle C and angle F have to be the same because they're between the 11 and the 13. So if they're congruent, if they're the same, you set them equal and you solve. The first thing we need to do is get rid of that 5. And then the last thing we need to do is divide by 2. 45 divided by 2 is 22.5. So x is 22.5. And one of the most complex parts about side-side-side congruence is actually proving that those sides are in fact congruent. So let's say I have this triangle on the left, and I will, pretty basic, A, B, C. And I want to know if it's congruent to this triangle on the right, D, E, F. I don't know why I keep picking those letters, because they're simple. So what you need to do is you need to understand what those side lengths are. It's easy to find the lengths of vertical or horizontal because you can just count. So I could easily count from A to C is 1, 2, 3, 4, 5, 6. So A to C is 6. I could also easily count F to D. 1, 2, 3, 4, 5, 6. Good. So far I have AC and DF are congruent, so that's the S. I need to find 2 more S's to do side, side, side. You can't just count A to B because they're at an angle, so you actually have to use the distance formula. A is located at negative 1, 2, 3, 4, 5, 6, 7, negative 7, 2. And B is located at negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, 6. Remember to label them x1, y1, x2, y2, and then we're going to plug it into the distance formula. The distance formula is the change in x squared plus the change in y squared. So let's see, my x2 is negative 5 minus my x1 is negative 7 plus my y2 is 6 minus my y1 is 2. Just simplifying it, I know that a negative and a negative right next to each other means plus. So negative 7 plus 2 is 2. 6 minus 2 is 4. And if I square that 2, I get 4. If I square that 4, I get 16. So that's the square root of 16 plus 4, 20. So we get that AB is the square root of 20, and if we do it again for, I don't know, maybe it looks like it's the same as FE. I'm going to start by finding the location. F is located at 1, 2, 3, 4, negative 1. E is located at 1, 2, 3, 4, 5, 6, 6, negative 4. Label your points, x1, y1, x2, y2, and then plug them into the distance formula. So that's the change in x squared plus the change in y squared. So that's 6 minus 4 squared plus negative 4 minus negative 1 squared. 6 minus 4 is 2. A negative and negative make up positive, so negative 4 plus 1 is negative 3. And then we square them and add them. So that's the square root of 4 plus 9, which gives us the square root of 13. So right off we know that AB is not the same thing as FE. And just to double check, just to make sure, we're not going to just say that it's not side, side, side yet, because BC could be the square root of 13. I know it doesn't look like it, but we're going to check by doing the distance formula. So you start by finding out that B is located at negative 1, 2, 3, 4, 5. 1, 2, 3, 6. And C is located at negative 1, 2. And then we're going to plug it into the distance formula. So right off, we know that the square root of 32 is not the same thing as square root of 13, so is this congruent by side, side, side? No. In fact, they're not congruent.